Welcome back to our third video on pointers. In the previous video, we looked at how we can declare pointers and how you can assign a value or access a value pointed by the pointer. And we also showed you the link between pointers and arrays and how you can access elements of an array using pointers and how you can actually interchangeably use pointers to assign values to an array, or how you can actually take the name of an array and assign it to a pointer. In this video, we're going to show you some more concepts on the pointers, starting with the concept of pointer of a pointer. What is it? We should have a depiction of this, but just in passing, what we are saying is a pointer can have an address of another pointer. So it means this pointer is pointing to a pointer, not as we have seen before, where maybe a pointer was pointing to a normal variable. It was getting the address of a normal variable, but here we are saying it can get the address of a pointer. In most cases, we are not going to be using point of pointers, but we are here just to demonstrate to you that it's possible in C++ to have a pointer of a pointer. But in many cases, the scenarios that we are going to meet will actually permit you just to use a pointer. And we should avoid having a chain of pointers. Having a point of a pointer of a pointer, of course, it will allow us to do so in C++. But it may be difficult to maintain such program or code. So here's a concept of pointer of pointers. Assuming that we have the normal variable, which is called d, declared, and that normal variable is declared and stored somewhere here with address 1001, and we should assume that this variable d has got a value 20. So this is a normal variable. And assume we have declared another variable, which is a variable c, and this variable is a pointer, which is on the address 1004, and this pointer is pointing to the ordinary or the actual variable. And in other words, it's keeping the address of the actual variable, which is 1001. Okay, 1001. So it's keeping the address. So this is a pointer pointing to d, and the d has got the actual value, but this one is keeping the address of this. So for us to have this, then we can have something, for example, as int, then we have our asterisk c. And this asterisk c is actually having the address of d. So what we have here is what we have depicted above here. We have the address of d stored on c. The c is a pointer. But we can also have another pointer declared, which is pointer number b, but this pointer number b is not pointing to any ordinary variable, but is pointing to pointer c. So anyway, this b, first of all, let's give it the address, is on address number probably 007, and is pointing to pointer c. So the value for b will be what? Just a moment. Think about it. What would be the value of b if b is a pointer of c? So it will be 1004, which is the address of c. So b is storing the address of c, and c is storing the address of d. So b is said to be a pointer of a pointer. It's not pointing to the ordinary value directly, is pointing to another pointer. So the point of pointers, you can have even another pointer here, which is called the A. Okay, maybe before we do this, let's see how this can be declared. So we can have a pointer of a pointer, maybe int B, which is asterisk. Because this one is a point of a pointer and it's a two-level pointer, we should have two asterisks when we're making our declaration. So we have pointer B, which is pointing to the address of C. So we should take note of two asterisks here, that this one, the two asterisks is just indicating to us that this one is not pointing to the normal variable, but it's pointing to another pointer, like this. Okay, so let's see A. If A is pointing to B, what will happen is our A, let's assume, is on address 101010. Our A will have the address of B, which is 1007. So A is pointing B, and B is pointing C, and C is finally pointing the ordinary value. So the declaration of A, okay, will be blah 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 blah, then 3 stars, then 3 stars here, then A, which is pointing to the address of B. Okay, so for us to display the value of A, if we have all these declarations and the A was declared and given the value of 20, value of D, sorry, and it was given a value 20, then we can display the value of D using any of these cout statements. Assume that these are cout statements. So the first cout statement, we can display the value of D using this statement. So we can have cout D will give us 20. Or we can have blah 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 cout using this this pointer. We can have cout and we just dereference it once. Cout C, it is going to give us 20. And we can of course even use cout B with two dereference operators, and it's going to give us 20. So this is B, and of course finally with the three operators, cout with three operators, three dereference operators, star 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 A is also going to give us 20. So we can access that value using any of that. If, for example, we take this with two asterisks B, what we are trying to do, the first asterisk is going to take us from here to here. So the first asterisk, if we just use the one asterisk, is going to give us the value which is on C, and that is 1001. If we can just use one asterisk here, it's not going to give us 20, it's going to give us the address for C, which is contained on C. So it's going to give us 1001. But two asterisks, it means the first asterisk is going to take us here and another asterisk is going to take us here. Okay, you are urged to try these things. Make sure you practice these things and appreciate them in C++. Thank you. So that's the concept of point of pointers. And for this video, let's stop by looking at functions and pointers. It's possible to have or to send a pointer to a function or return a pointer from a function. So how do we do that? When we want to come up with a function that will actually have pointers as parameters, then when we are declaring that function or we are coming up with a header of that function, we have to specify that this will actually receive function. It will receive the parameters of pointers. So by putting this star, it means it's going to receive the address and not the actual value. The pointers are very important when we are working with very big data, as is the case with the reference parameters. So instead of sending the whole chunk of data, the whole chunk of value to a function, we can just send the address. The implication is similar to that of reference operators, because you have sent the address. The changes that you make in the function is going to affect the value, or the value of the variable in the caller, because it's the address which was sent. So this is how you declare. So if you have your maybe variable name, in the function name, then you can have your parameter and you put a star or this asterisk symbol to show that this one is going to receive an address. So when you're making a call, you can send the pointer, the variable, or you can send something like this. This one is taking the normal variable and getting the address of this, and that address is being sent here. But if in the caller you declared a variable, a pointer, and that pointer was assigned some value, then that pointer can just be sent directly here. But here we are assuming there was no pointer declared, but we have a normal variable called number, and we want the address of a number to be sent to a function. So you have the address of number sent. Okay, and you can also, of course, return the pointer from a function. For us to return a pointer from a function, it means our return statement return type should also be indicated as such. Of course, for this one is returning nothing, but if it's to return something, maybe it's returning a pointer of type integer, then our return type was supposed to have something like this. So, and of course you can have the function name here, and you have the list of parameters whatsoever. So what we are having here now is a return type of pointer. So this function is going to return something, but what should be returned is an address or a pointer. We do not condone to return the address of a local variable. So if you declared something inside this function, assuming this is a function, and inside this function you declared something as a pointer, maybe pointer A, and of course it was given whatever address here, assuming, but it's a pointer A, we do not condone to have something like return A, because you are returning the address of a local variable, and this local variable is stored on the stack. Remember, when you have variables on a stack, the moment that stack is destroyed, or the moment we finish executing this function, then all the variables that were created are destroyed. So you are going to return a pointer address, or the address to the caller, but now that address will be pointing to something which has been released. But when we are working with the dynamic memory allocation, it will be possible for us to return the address of that dynamic memory allocated, because the memory allocated on the heap has got a lifespan beyond the function. Okay, so we are going to have a better example to demonstrate this in our practical videos, but here we have just demonstrated or explained the concept. Points to note: the pointers can be sent to a function, and that function, to receive a pointer, we have to declare a parameter of pointer, and the function can return a pointer, and make sure that the returned data type is a pointer. You should never return the address of a local variable that is stored on the stack. Never, 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 never. But there will be a situation where you would want to return the address of something, especially those that have been allocated on the heap. Very important. So this is what we wanted to have in this video. Two concepts, point of a pointer and functions and pointers. Thank you. See you in the next video when we'll be talking of dynamic memory allocation, working with a heap memory in C++.